Right. So in the previous video, we looked at the group 1 metals, the alkaline metals. We looked at their physical properties. We said that they are soft, they have low density, low melting and boiling point. Again, they are good conductors of what? Heat and electricity, and they are shiny. Now, this video looks at their chemical properties. We will look at how they react with water, how they react with oxygen and chlorine. Now, we will first of all look at the general trend of their reactivity. What happens as you go down the group? That's reactivity increases or decreases, and why. Okay, so let's look at their reactivity. What happens as you go down the group? Now, as you go down the group, reactivity increases. Now, questions are normally asked, why does reactivity increases as you go down the group? And you should be able to explain. Now, if you look at this, we said in the previous video that as you go down the group, the size of the atoms increases. The atoms become bigger down the group. Now, what that means is that the outer electron get further away from the nucleus, and the further an electron is from the nucleus, the easier it is to be lost in what reactions. And this is why the reactivity of the alkaline metals increases down the group. Now, if you look at here, you will see that the distance between this outer electron and the nucleus is smaller than the distance between this outer electron and the nucleus in sodium. Again, the distance between the outer electron and the nucleus in potassium is bigger. Now, what we are saying is that the bigger the distance, the more easy it is for the electron to be lost in reaction, and therefore the more reactive that particular metal. Okay, now since the size of the atom increases down the group, they become more reactive because it's easier to remove the outer electron in reactions. Okay, and that's why reactivity increases as you go down the group. Now, these type of questions normally come in your exams, so pay attention to them. Now, let's look at how alkaline metals react specifically with oxygen. Remember, I said in the previous video that they are so reactive that we normally keep them, for example, sodium, lithium and potassium, we keep them in oil. Now, this is to prevent them from reacting with atmospheric oxygen and water vapor. When you cut any of them fleshly, they are shiny, but within seconds they start reacting with oxygen and they form a dull metal oxide. Okay, so alkaline metals react with what? Oxygen to form metal oxide. Now, this produces a layer of dull oxide on the surface, and that's why when you cut lithium, for example, at first it looks shiny. Within few seconds it starts getting dull. Now, the dull is the metal oxide being formed. Okay, now the speed with which these alkaline metals react with oxygen increases as you go down the group. Now, we just said that reactivity increases going down the group. Okay, now what you also have to know is that the type of reaction between the alkaline metals and oxygen is oxidation, because there is loss of outer electron of the alkaline metals. And remember, we said when we were doing electrolysis that oxidation is loss of electrons and reduction is gain of what? Electrons. Okay, now let's look at the oxidation equation. Now, you have to be able to write balanced equation, full balanced symbol equation of the alkaline metals reaction with oxygen. Okay, So let's look at lithium. If lithium reacts with oxygen, you will get lithium oxide. Remember, we said that the alkaline metals react with oxygen to produce metal oxide. Okay, and so if lithium reacts with oxygen to form lithium oxide, what product will be formed if sodium reacts with oxygen? Pause the video and write it down. So we have lithium reacting with oxygen to produce what? Lithium 2 oxide. You should be able to write down a full balance equation, especially for the higher tier students. Okay, now if sodium reacts with oxygen, we're going to have sodium oxide. Again, the alkaline metals react with oxygen to produce metal oxide. So if lithium is going to react with oxygen to produce lithium oxide, then sodium will react to produce sodium oxide. Okay, what product are we going to get if potassium reacts with oxygen? Pause the video and write it down. Now, so this will be the full equation. If we react sodium with oxygen, we're going to have sodium oxide. Pay attention to the full balance equation. Okay, now because the reaction of the alkaline metals with oxygen is oxidation, you should be able to write down the ionic equation too. So over here we have sodium becoming sodium 1 plus an electron here. Now what is happening is that sodium loses 1 electron to form a positive ion with a charge of +1. Okay, and this is the electronic configuration. You should be able to write down the ionic equation of that oxidation reaction. Now if this is sodium, write down the oxidation reaction for lithium and potassium. Okay, lithium and potassium. Pause the video and write it down. Now, how do alkaline metals react with water? Okay, how do they react with water? We said that they react with oxygen to produce metal oxide. Now, what happens when they react with water? Now, all alkaline metals react vigorously with water. Okay, indeed, the reaction becomes more vigorous as you go down the group. As you go down the group, the reaction becomes more vigorous. Again, the reaction of alkaline metals with water is exothermic. Now, what does that mean? It means that when they react with water, heat is released to the surroundings. Okay, heat is released to the surroundings, and a lot of them. The reaction produces also a gas, and what happens is that the gas that is produced ignites a lighter spring with a squeaky pop. Now you should be able to identify what type of gas ignites a lighter spring with a squeaky pop. What type of gas is that? Write it down. Again, when green universal indicator is added to the reaction mixture, it turns purple. What does that tell you? When alkaline metals react with water, they produce a product. The reaction mixture, the product, when we add universal indicator, it turns purple. What does that tell you? Now this is here we're talking about whether they are acidic or basic. So if the reaction mixture turns purple, what product do we get? And again, the gas that's produced also ignites a lighter spring with a squeaky pop. What gas is that? Pause the video and write it down. Now, water reaction with alkaline metals, we said that water reacts with alkaline metals to produce hydroxide ion or metal hydroxide. Now what this means is that if lithium reacts with water, we're going to have lithium hydroxide. Okay, we're going to have lithium hydroxide. What product are we going to get if sodium reacts with water? If lithium reacts with water, we are going to get lithium hydroxide. And remember, we talked about another gas that is produced, which is hydrogen. Okay, so we're going to have lithium hydroxide and hydrogen. What product are we going to get if sodium reacts with water? If sodium reacts with water, what product are we going to get? Pause the video and write it down. Pause the video and write it down. So this is the general equation of alkaline metals reaction with what water. We get alkaline metal hydroxide and hydrogen. Alright, now how does lithium specifically react with water? Now lithium is the least reactive of all the metals. Now why do you think so? Why do you think lithium is the least reactive of all the metals? Now because lithium's position on top of the group. Okay, remember that we said that reactivity increases going down the group. Okay, so when added to water, lithium fizzles and moves around slowly across the surface of the water. Okay, when we add lithium, we drop lithium onto water, it fizzles and moves slowly across the water. Now this will be the reaction. This will be the full reaction. You must take note of the full balance equation when lithium reacts with water. Alright, the full balance equation when lithium reacts with water. Now if lithium reacts with water, we're going to have lithium hydroxide and hydrogen. Okay, what are we going to get if sodium reacts with water? Remember that we said that when they react, we get metal hydroxide. So we have lithium hydroxide here and hydrogen. If lithium is going to produce lithium hydroxide, what are we going to get if sodium reacts with water? Okay, so sodium reacting with water, what happens? When sodium reacts with water, it fizzles more than lithium and moves quickly across the surface of water. So like lithium, sodium fizzles also, but it fizzles more than lithium and also moves across the surface, albeit faster. Again, sodium melt as it reacts and become spherical and shiny like a ball bearing. Alright, now hydrogen sometimes catches fire because of the heat from the reaction. So you should be able to write the balance equation when sodium reacts with water. Now the characteristic feature of sodium reaction with water is that it fizzles more than lithium, it moves quickly across the surface of the water, the sodium melts under the heat and becomes spherical and shiny, and sometimes the hydrogen catches fire. Okay, pay attention to the balance equation of the reaction of sodium with water. What about potassium? What happens when we drop a piece of potassium in water? When we add water to potassium, potassium moves across the surface of water very quickly. Like sodium, it melts with the heat of the reaction. The reaction produces so much heat that the hydrogen catches fire. Okay, so similar to sodium, the hydrogen catches fire it moves across the surface of water